Hi everyone. Today we are going to discuss most important subject in the computer science, that is algorithm. So presented by Manoj. So let's see the definition of the algorithm here. An algorithm is a finite sequence of instruction, each of which has a clear meaning and can be performed with a finite amount of effort in finite length of time. So that is also okay. Again, you can able to give one more definition I will give you. It is a combination of sequence of finite steps to solve a problem. So we're going to have some sequence finite steps to any kind of problem. Example, I have given a problem, we can able to see. Think like that I will going to take an array which is unsorted array. Okay, I will give it to the machine with a finite amount of time or with finite amount of steps. What it will going to do, it will going to calculate that one, nothing but it will going to compute that one. So finally it will going to give you the answer with the sorted list, nothing but sorted array. So whatever the thing you have given that is unsorted array, that will be after computation with finite amount of time, okay, and finite amount of steps it will going to take. Again it will going to give you the sorted one. So that is what we call it as so here we will going to take input as a raw data, again finally useful information we are converting, that is output. So this is what exactly we need to understand about here. We are looking at only thing is finite sequence of instructions, nothing but finite number of steps is required to convert this unsorted data into sorted data. That is what exactly we need to understand. We have to use the finite steps to solve any kind of problem. This is what the definition of algorithm. So you can able to see finiteness is nothing but the algorithm should be finite. So then there is no infinite loop. Suppose if you, for example, if you go to while one, okay, when you mention printf, automatically what happens, it will take infinite times, so that we don't know when it will going to stop that execution. But so if that case means what happens, definitely we cannot able to get the results. So finally maybe 2 years we will want to get the results, or 10 years, we don't know exactly. It will be in the finite loop. For example, while one, okay, for example I will show you here. Just a moment. Hmm, just a moment. Suppose example you can able to see, sorry, just a minute. Okay. So while example you can able to see while if I say 1, so actually it is true, while 1 is true. So what I will going to do, I will going to write some statement printf, okay, printf. Again here I will going to put some anything like string value or whatever it may be, we will going to place here. So this is the small program. Again what I will going to do, I will going to run this program. What happens, hence while one it is a true condition, what happens, continuously it will start executing, infinite loop will going to happen. These kind of results are not good in algorithm. It should give proper result. Again, it should take some proper finite steps to solve the problem. That is what exactly we are talking about. Again, input 0 or 1 or more inputs. Oh, it can take 0 inputs or more, 1 or more inputs. That is left to the designer. Okay, output, at least one output it has to produce. Okay, so whatever, see in this program what happens here, the program says that very clearly. So I'm not going to give you not even a single output. It is saying that continuously it is running like loop, continuously it is running. So that is one big problem. Again, effectiveness, instructions are realized, for example, performed in a finite time. So whatever the instructions you have provided to the computer, it should be realistic. So that's what exactly, if it is realistic, definitely it will going to perform in a finite amount of time. Suppose you wanted to calculate addition of two numbers, okay, give a variable a and b. Again c is equal to a plus b. So these are all finite instructions you are providing. If you are not providing proper finite instructions, definitely it will go into the infinite loop. So whatever the instruction, this is also good instructions, but I will tell you these are not all not the proper instructions, what I am telling you people. See, So this while always I am making the conditions true. Okay, that is also good instruction. But what happens? The output, we are not getting the output. At least one single output we are not getting. Here continuously we are getting the output. It is not stopping. We don't know exactly what is the correct output like that. Okay. Definiteness, no ambiguity in the instructions. For example, multiple way of instructions can be performed without confusion. So many instructions you will going to give so that it will going to create the ambiguity. This is the small problems we have to avoid in algorithms. So let's go to the next slide. We are going to see more about this. So here, properties of algorithm, very, very important one. So what are the properties the algorithm is going to have? It should terminate after finite time. So that is what exactly I told you. When you take any example, so for example, I will going to write a program for you people so that you will going to understand. So see here, it should terminate after a finite time. Suppose example, you can able to see here, when I write a program, see here there is an instruction printf hello world. So when I run this program, it will take a finite instruction. Again, it will going to run. Again, it will going to give a perfect answer. So this is what only one time it will going to run. That is a finite time, one time, two times, three times, whatever it may be. It is a finite time. Suppose what I will going to do, I will going to say while, okay. So here I will going to put one. So because I wanted to make always true, this while condition always true. What happens here? You can able to see here. So here I will put the bracket here so that, so and run it now. See, you are getting infinite loop. We don't know what is the real answer, what is the exact answer. We will not going to get it. This is not a finite one. This is an infinite. It should not happen in this way. That is what exactly we need to understand about this one. Okay. Again, it should produce at least one output. When I run this program, you can able to see this one. When I run this program, basically what happens here, it is not giving proper output. It is not giving single output. It is giving multiple outputs. Here you can able to see it is giving multiple output. So that is the reason why it says that it is not a good algorithm. So that is what exactly we need to understand. It is dependent on independent on programming language. See, whatever the algorithm you will going to write, these are all completely we will call it as pseudocode. Algorithms are always we will call it as pseudocode. Whatever the program you will going to write, so that is not depend on algorithm. Algorithm is a pseudocode which can, whatever the algorithm you know, you can convert into any programming language. That is the reason why they will going to say independent of programming language. If I write any algorithm, if I write an algorithm for adding two numbers, if I write an algorithm for leap year or finding any greater number, whatever it may be. So what happens here, that can be I can written in Java, C++ or Python, Ruby, whatever it may be. I can write it, whatever we want it. Okay, so that's why it is totally independent of programming language. Every statement in the algorithm should be deterministic. Okay, so here what happens here? So when you are giving any statement, it should determine okay what exactly it is doing. Suppose example you can able to see when I writing this statement. So when I writing this statement, see here, this statement indicates very clearly it is printing the hello word. It should be deterministic. So that is what exactly we need to understand about a deterministic. Again, every statement in the algorithm should be efficient. Whatever the, suppose example, see, I will going to write a statement, so many statements, but which are not necessary. For example, I will going to write a program, small program here. Uh, uh, example, I wanted to write integer x, okay, comma, again integer y, comma, again here I will going to printf, okay. So here I will going to say double quotes percentage d, okay, just I wanted to print the value of x. So that's it. So give some value to x now. Okay, give some value to x. So that is I will want to give some value to x. So what it says that very clearly, you can able to see this one. Every statement in algorithm should be efficient. Okay, so we have to use that statement. See, when I run this program actually, so you can able to see when I run this program, it is giving 10, but I'm not using this y. Okay, it is not efficient. Where I'm using this program, I'm not at all using this program. So that's why what happens here. So this is not, these statements are unnecessary. We are not using. There is no efficiency. We are not using unnecessarily. We are consuming the memory. That is what exactly is this. So this is all about properties of algorithm. If you want it, you can able to update it this one, y is equal to some value. Okay, y is equal to, you can update it to 45 like that and use it. This is a valid one. This is the statement is valid now. Okay, when I print this one percentage, so this become a valid one. It says that very clearly, whatever the variables or whatever the statements you will going to create, that statement should be efficient. I wanted my statement is efficient here because I wanted to print the value of x as well as y. So when I run this one, automatically you can able to find the value of x as well as y. So that is the reason why these statements are efficient. It's doing its work. That is what exactly I'm using for something. That is what. So this is all about properties of algorithm. Thank you. Please share and subscribe. Thank you very much.